Good afternoon, respected teacher and dear classmates. Assalamu alaikum. I am Humayun Ahmed from the Department of CSC. My ID is 23521352. Today I am presenting my final term project for the Digital Logic Circuit course. The guardians of our faculty is Nafiz Ahmed Chisti sir. The title of my project is Digital Parking Control System. The system is designed to monitor and manage parking spaces using digital components like flip-flops, timer, counters, and finite state machines. Here is the content that I will discuss after. The first one is the contest, then the task 1, and then the pre-calculation. After that, the task 2 and task 3, and then the conclusion part is that the limitation. So designing. So first of all, the contest of this total project is that designing a parking garage with display showing the availability, set the maximum limit of cars for parking, count the number of cars entering and exiting, and display full or space available on the space ability. After that, the first task 1 is that the objects of the task 1 is that the draw a block diagram and flow a diagram, and then the draw the appropriate architecture of the counter. Here is so in my ID the available space in the garage is AGAs, which is 252, that's 9, and then 9 the max. So it is the maximum ability of this garage, and after that the 9 is the decimal number, the binary number is 1001. It represents the 4-bit. It represents the binary, the 4-bit. After that, the first one is I will discuss about the block diagram. So at the very beginning we have two sensor, one placed at the entrance and then the other at the exit. This detect whenever a car enters or the leaves the parking area. Then the signal from the entry and exit sensor go to the 4-bit up down synchronous counter. Then a clock pulse ensure that the counter works synchronously and update the count in real time. Then the output from the counter is stored in a register which temporarily holds the current count for comparison. After that, a keypad allows the user to input the maximum capacity, which is then passed through an encoder and stored in another register for comparison. The values from the two registers are then compared. If the current count is equal to the maximum capacity, it sends a signal with signal to show display full. If the current count is less than the maximum capacity, it activates the 555 timer. After that I will discuss about the flow diagram. The processing begins when either the entry and exit sensor is triggered. Based on the sensor input, the counter is incremented for entry and it is decremented for exit. The counter output is stored temporarily in register A that leave count to this is the live count of vehicles, and then the user define the maximum parking capacity set via keypad and the store in register B. This is compared with the current count. If A equal to B, then the system shows display full message. If A less than B, the system activates the space available message with blinking effect using the 555 timer. After that I will after that my ID is that 9, so I will so I am using a 4-bit synchronous counter. Here is my 4-bit synchronous counter. uh, that's the task 1. After that we will shift about the task 2. So task 2, there is the number of maximum cards, AGAs, which is 2 plus 5 plus 2 equal to 9, converting 9 from decimal to binary 1001. Here the number of bits is 4. And then also the tax, there is given the P, which is 26, and the duty cycle 100 minus 26 is which is 74%, and F equal to A plus D plus 2 hertz equal to 6 hertz. And then we will shift about the why am I using the 555 counter or 555 counter in this task. For continuously displaying full stable mode of the timer is utilized to as it can given continuously a square curve with a frequency of 60 Hz. The human eye can see at continuously at 60 Hz. After that there are the for blinking display. We are also the stable mode, because the blinking was so so that the blinking is very continuously using. And then so in the task 2 we can in the task 2, here is we can see that the P and the F and the D, which is given, or I also wrote this and to calculate, sorry, I also calculate this I also calculate the value P equal to 26, F equal to 6 hertz, and D, which is the duty cycle 74%. And also also I calculated TH value, which is 0.123 second, and TL is 0.0436 second. And also here I also calculated the R1 and R2. So the R2 is 251.66 ohm, and then TH, which then also the R1 is 458.29 ohm. So additional sequential and combination logic component, which is I also used in this project, D flip flop, which is store and counts entry and exit, counter count total cards, comparator check garbage full or not, and the logic gate control 555 timer. There are two timers being used in this system. One is in monostable mode and another is in stable mode. There is a due to the display pattern is space available is displayed in a blinking fashion, and therefore it is connected to a it is also connected to a timer in a stable mode, and then and the display full is connected to a timer in a monostable mode. The first one is the timer is that space available. We can see that there is R1 and R2. Everybody knows about that. The stable mode, we are using two capacitor, and also in the monostable timer we are using only one register. That's why there is the R2 equal to 0 and R1 has own value, which is 709.95 ohm. Ohm in this figure, and also we can show that in the full display is constant. I have decided to use another timer in a stable mode for the smooth counting. That's also part of tax 2. And then the tax 3, tax 3 which is related to the tax 2 value, where I calculated the TA's value is 123, and then TL is 43.6 ms, which means millisecond, which is greater than the both TH and TL, which is greater than the 4, which is greater to the 4. Here we can also see that there are also the clock period, which is included in a 1 millisecond. We will get we will get 8 steps. Each consist of 1 millisecond. After that, for the blinking control of the space available message, I designed a finite state machine, or FSM. The purpose of the FSM is to alternate the display between on and off. According to the instruction, the output should remain on for TH millisecond, and off is TL millisecond. However, for this task, both TN and TR are limited. TH and TL are limited to a maximum of 4 millisecond. The MSM is designed with 8 state. The 4 state produce a high output, which is triple A, and then and the next 4 states produce a low output represented of time. This is the sequence of BBBB. Smooth blinking pattern. And also we can see that the table here is the reset button, which the present state is don't care, and the next step will be 0, and then output is 0 0. Output is 0 0. After that, the next step will shift into the present step, and also the present step, also the next step continuously working. And then the Verilog code, where we can write to the the table. To implement the FSM practically, I wrote Verilog HDL code that produces the output signal for the blinking pattern. The module takes clock and reset as input and provides a signal output that alternates between high and low. Inside always the block, a case statement is used to handle different state. Here we can see that A, where is the present state not present state 2 not 2 bar, present state 1 bar, and the present state also 0 the bar. After that, it was continuously working. This HDL code allows us to simulate and test FSM before actual hardware implementation. And then last part, drawback and the limitation. There are plenty of limitation for the developed system. That is the point of issue that arise, which is that the counter is not modified to only count until 9, which it is a 4-bit counter. It will go up to 15. So if a car comes in despite the display showcasing full, the sensor will increment the counter for a greater capacity. The counter needs to be a higher bit, and the number is that given to the decoder as has to be increased accordingly. The register need to be adjusted as well. The specification which bit to use depends on the increment and then capacity, and this enhancement would make the system more scalable and user friendly. That's all my part. Thank you everyone. Thank you our teacher.